Okay, so for lesson three, we're going to be talking about rational expressions. So this is probably everybody's like least favorite unit that we've done. Um, so a lot of this is knowing how to factor. So if you're stuck on factoring, make sure you go back to lesson two and really watch that video and make sure you feel good about it. But what we're going to do is we're going to start with number one. We're going to factor the top and the bottom and see if anything cancels out. So if we look at number one, the top is a difference of squares. So we would have x plus 5, x minus 5. And on the bottom, the only thing we have is a GCF. So I would factor out a 4, and we have x minus 5 left over. So what we're looking for is if anything is going to cancel on the top and the bottom. So we have an x minus 5 on the top and the bottom, so those cancel out. So all we're left with is x plus 5 over 4. And that would be our simplified answer. So I also want to show you how you can check that answer in Desmos. So if you go to Desmos graphing calculator, then you'll see that you have just this line when you type in the original function. So type in the original, and then what we do is type in our answer. So I'm going to type in x plus 5 over 4, and make sure that that line that pops up is exactly the same as the red line. And that's your way of checking your answer. So if you were doing like a multiple choice question, you could just type everything in and check it. So let's go back and let's do another example. So on the top, we have a GCF of 2. So I'm going to take 2 out, and we're going to have 5x minus 2. On the bottom, we have a GCF. We don't have any GCF, but we want to rearrange this because we always want our x to be first. So what I'm going to do is I'm going to factor out a negative, and that would make this positive 5x and make our 2 negative. So we would cancel these out, and we would have just negative 2 left over. All right, and then for the next one, we have 3x minus 15 on the top. Our GCF would be 3x minus 5 over, and then we need to factor, so figure out what multiplies to 10 adds to negative 7. So it'd be x minus 5, x minus 2. Again, our x minus 5's cancel, so we're just left with 3 over x minus 2. All right, so we're going to do some more examples with simplifying because it kind of is part of all the rest of this page too. So now we're going to multiply. So there's kind of a couple ways you can think about multiplication. You can multiply everything straight across, and that's kind of the easiest thing to do when you have all these different letters like you do on number 4. So I'm going to go ahead and just multiply straight across first. So I have a 5 out front. I have a squared. There's no other a's on the top if we just like make this one big fraction. So I'm just going to leave it a squared. B though, we have one b here and two b's here. So we would have 3 b's up top total. And then we just have c to the 4th. And then on the bottom, put your number first. So we have 25, a cubed. There's no other a's. B cubed. And c to the 4th. So I'm just putting them A, B, C order just to make it easier to look at. So if we look at this now, we want to simplify what we can. So we have 5 over 25. If you were to type that into a calculator and turn it into a fraction, it turns it into 1 over 5. And then we have 2 a's up top, 3 on the bottom. So we would have 1 left on the bottom. So remember, we subtract our exponents, or if you want to think about it like you have 2 a's up top and 3 on the bottom, cross off what you have, or like the duplicates, and then you just have 1 left on the bottom. So we have 3 b's up top and on the bottom, so those cancel each other out, and same thing with the c to the 4. So that would end up being our final answer. And I'm just going to shorten this a little bit. So 1 over 5a. So if we look at number 5, now we have like factors, or we have groups that we have to kind of worry about. So this is where it's easier to cross cancel. So we're not going to multiply anything yet. So we're looking to see if we can factor everything and then see if there's anything that's a duplicate on the top and the bottom. So 5x minus 7, we can't do anything with. So I'm just going to leave it like that. Over. And remember, we always want our x to be first in this situation. So we can divide both 12 and 3 by 3. And I'm going to divide by -3 to get my x first. So to get that x positive. So this would be x minus 4. Then we have x minus 4, which can't do anything to factor it. And on the bottom, this is where we want to flip this around. We want this to be positive. So I'm going to factor out a negative, and then we'll have 5x minus 7. So it just switches everything around. All right, so now here is where we look for anything on the top and the bottom that cancels out. So if I were to cross off, we have 5x minus 7, those cancel each other out. And then we have x minus 4, those cancel each other out. So then once we get there, we just multiply straight across. So we don't have anything left on the top, but remember, if you have nothing left, that means you have a 1 up top. Not a 0, a 1. And then on the bottom, we have -3 times -1, which is just +3. So our answer would be 1/3. And again, this is the type of problem. You could also type this into Desmos, and you could get your answer is 1/3. So it only works if all of your variables are x, but it's a really good way to check your answer. All right, and then for the next one, we're going to factor. So GCF for the numerator would be 4. So we'd have 2x minus 1 over x plus 4 we can't do anything with, times, so figure out what multiplies to 12 and adds to 7. That would be x plus 4, x plus 3. And then let's flip around the denominator here. So we want this to come first. So I'm going to factor out a -1. And we're going to have 2x minus 1. Okay, so then we look to see if there's anything we can cancel out. So we have a 2x minus 1 on the top and the bottom, and an x plus 4 on the top and the bottom. And then we just multiply straight across. So we canceled what we could, and we would have 4x plus 3 over -1. And you might see this written, there's a couple different ways you could see it written in like a multiple choice question. You could see it written like this. You could also see it where the -4 is distributed in, so where it's -4x minus 12. So any of these answers I would have accepted, but they might look different depending on your multiple choice questions. All right, dividing. So dividing is basically the same as multiplication, we just have one extra step. So whenever we divide, we keep the first fraction the same, we change to multiplication, and then we flip the second fraction. So we would have this whole thing stays the same. So I'm just going to go ahead and factor it to like save myself some work. So figure out what multiplies to -8 and adds to -7. So it'd be x minus 8, x plus 1. Over, and then let's figure out what multiplies to -48 and adds to -2. So that would be x minus 8 and x plus 6. All right, we changed to multiplication, and then we're going to flip the second fraction. So that looks like we're going to change what's on top and what's on the bottom. So this is my new numerator. So I'm going to factor that. What multiplies to 6 and adds to 7? Be x plus 6, x plus 1. And then on the bottom, now we have this. So that one just has a GCF of 6x. So x minus 1 is what's left. So then we look for anything that will cancel out. So we have x minus 8 on top and bottom. We have x plus 6 on the top and the bottom. And then nothing else is going to cancel out. So let's go ahead and multiply straight across and see what we have. So we would have x plus 1, x plus 1 on top, and then 6x over x, or times x minus 1 on the bottom. So that's one way you might see your answer. You might see the top like foiled out. You might see the bottom distributed. So kind of know that, like, yes, this is your answer, but if you have to, it's also the same as x plus 1 squared over 6x times x minus 1. Or if it really wants to test you, that whole thing multiplied out, which would be x squared plus 2x plus 1 over 6x squared minus 6x. So all of these are the same. All of these are correct answers. So you need to know that if you see any of these different, like if you get this first answer, but this is the multiple choice, you know to pick that one. All right, for number 8, now we have it in a different form, but it's the same exact type of question. So we're still dividing. So what we're going to do is rewrite this. So this is the same thing as 15x squared minus 12x over 36x plus 45. So that's our numerator. And then we're going to keep change flip. So we kept the numerator the same. We're going to change to multiplication, and we're going to flip this fraction over. So I'm going to have 24x plus 30 on top now, and 15x squared plus 3x minus 12 on the bottom. All right, and then we're just going to do the same exact thing we've been doing. So we're going to factor what we can. We have a GCF of 3x, so we'd have 5x minus 4 left over. On the bottom, we have a GCF of 9. 4x plus 5 is left over. And then we have a GCF of 6. Divide both of those by 6, we get 4x plus 5. And then on the bottom, figure out, so we have a GCF. So our GCF is 3, and we have 5x squared plus x minus 4. So go through the steps of factoring. You'll have to do factoring by grouping for that one because a is not 1. So we are now going, or I'm just going to skip all of that because that's part of our last video. So our answer would be 5x minus 4x plus 1. And then let's cancel what we can. So we have a 4x plus 5 on the top and the bottom. We have a 5x minus 4 on the top and the bottom. And then let's look at our numbers. So this is where either you just want to multiply the numbers and then simplify, or you can kind of cross cancel. So if we think about it, we have a 3 and a 3. Those cancel each other out. And then 6 divided by 9 is going to leave us with 2/3. So we don't have that much left. So let's look what we do have left. We have an x up top. We have a 2 up top. So 2x. And that's it. And then on the bottom, we have a 3. And then we have an x plus 1. Okay. So next thing is addition and subtraction. So this is like probably the tougher portion of this because it requires you get a common denominator. So if you look at number 9, you want to first see if they have a common denominator. So they have the exact same denominator. So we don't have to do any extra thinking or any extra work for this. So we're just going to go ahead and subtract what's on top. So be careful, because if we have a subtraction problem, it has to be distributed into this entire numerator. So our common denominator is a squared minus 36, because we want them to be the same. They already are. So we're going to have 5a minus a plus 24 on the top. So it's helpful to write it as one fraction, and then we're going to distribute and then simplify. So we have 5a minus a, if we distribute that negative in, minus 24 over a squared minus 36. All right, and then we're going to figure out 5a minus a is 4a minus 24 over a squared minus 36. Okay, so all I did was just combine the numerators. That's all we've done so far. And now what we're going to do is just treat this like a simplification problem, like we did on the first page. So figure out what's your GCF on top. In this case, it would be 4. We'd have a minus 6 left over. And then on the bottom, we have a difference of squares. So we would have a plus 6, a minus 6. All right, and then we cancel it if we can. We have a minus 6 on the top and the bottom. So our answer for this would be 4 over a plus 6. Okay? All right, and then if we look at this, whenever you see something that you can factor, you want to go ahead and factor it. So this is a perfect square trinomial. So to factor it, we would have 2x minus y, 2x minus y. So we're looking for what they already have in common. So they both already have one 2x minus y, but we need this one to have another one. So we're going to multiply by 2x minus y on the top and the bottom. And so what I'm going to do is I'm just going to go ahead and write it as one big fraction. And now we have a common denominator, which is going to be this original 2x minus y, 2x minus y. And we're going to put x squared up top because that's from the first fraction. And then I'm going to write the multiplication. So x minus y, 2x minus y. And so in our next step, we're going to FOIL that out. So we have x squared just from this first part, and then we're going to multiply. So we would have 2x squared minus xy minus 2xy plus y squared, all over our least common denominator, which I'm just going to write as 2x minus y squared. All right, and then we want to combine what we can up top. So we're going to have these two be added together, so 3x squared. These two are like terms, so we'd have minus 3xy plus y squared, all over 2x minus y squared. And we can't do anything else, so that would be our final answer. All right, and then for our last example of this, we need to find a common denominator again. So let's factor the bottom and the top. So on the bottom, we have a GCF of 4. So we'd have w minus 4 left over. On the other fraction, we have a GCF of 2. So w minus 4 again is left over. So they both have w minus 4. So I'm just going to write it over here to keep track of it. We have w minus 4. We don't have to multiply anything by that because they both have it. One has a 4 and one has a 2. So we want it to be 4 because that's the bigger number. So we would have to multiply this second fraction by 2 over 2 to get that denominator to have a 4 right here. So I'm going to go ahead and write that out. We have w plus 12. This first fraction isn't changing at all. Minus, and then we would have 2w plus 4 over 4w minus 4. So just multiplied by 2 on the top and the bottom. And then let's write it as one fraction and figure out if we can simplify on the top. So remember that w plus 12, that stays the same, but remember that this is the same thing as having a negative 2 because of that minus. So we need to distribute a negative 2 in to the top and the bottom. Oh my gosh, to both terms. And then we're going to have to combine like terms on the numerator. So we'd have w minus 2w, which is negative w. And then 12 minus 8 is positive 4. And then we have 4 times w minus 4 left on the bottom. So we can actually go a step further with this one. We want to see if we can simplify. So since we have that negative w plus 4 up top, I'm going to factor out a negative and make it w minus 4. And we have 4 times w minus 4 on the bottom. So we have a w minus 4 on the top and the bottom, so those cancel out. And we're just left with negative 1 over 4. So remember, if everything's gone on top, you just have a 1. And that would be your final answer. All right, so last thing for this part is figuring out how to solve a rational equation. So first thing we need to do is find our restricted domain. So our RD is just whatever makes the denominator 0 that can't be one of our answers. So if we look at all of our denominators, if we were to plug negative 1 in, it would make a denominator 0. If we were to plug 0 in, it would make a denominator 0. So for our LCD, our least common denominator, we want to look to see what the combination of the denominators is. So I factored this. So it has an x and it has an x plus 1. This one has an x, this one has an x plus 1. So our least common denominator would be x times x plus 1. So what we're going to do is multiply each fraction by that least common denominator. So we're going to multiply by x times x plus 1. On the top. And what we're going to do is write this out. So we would have 4x times x plus 1 over x plus 1 minus 5x times x plus 1 over x equals 20x x plus 1 over x plus 1. All right, so we're looking for what will cancel. So our goal, the whole reason for multiplying by the least common denominator is to cancel out every fraction and make it a way easier thing to solve. So if we look at this first fraction here, we have x plus 1 in the top and the bottom. Those cancel out, so we're just left with 4x. In the next one, we have the x's that cancel out. So we have that minus 5 still, and then x plus 1 in parentheses. And then in the last fraction, the x's cancel, and so does the x plus 1s. So all we're left with is 20. So what we're going to do is we're going to just solve this equation now. So we have 4x, distribute that negative 5 in. So we have negative 5x minus 5 equals 20. And we have negative x minus 5 equals 20 when we combine like terms. So we would have negative x equals 25. So x equals negative 25. So make sure to check that against your restricted domain we talked about. We can't have it be negative 1 or 1, and that's the case. So that answer works. All right, and then for the last one, so we have to find our least common denominator in our restricted domain. So we have an a in the denominator here. If it were negative 1, it would equal 0, so we can't have that. And then we have 1 here. If it were 0, it wouldn't work. So our LCD in this case, since there's nothing to factor, we're just going to multiply those two denominators together. So a times a plus 1. And always leave it in factored form to save yourself some work. So I'm going to multiply by a plus 1, a plus 1, a plus 1 on the top of all of these fractions. So we're going to have negative 4a times a plus 1 over a plus 1 plus 3a times a plus 1 over a equals a times a plus 1. And so then we're just going to cancel what we can. So if we look, we have a plus 1 on the top and the bottom. So we're just going to be left with negative 4a. We have just an a in the top and the bottom, so we're going to have plus 3a plus 1 equals, and then we don't have a denominator for this part, so there's nothing that's going to cancel out. So equals that a times a plus 1. So now we're going to just combine like terms, distribute, multiply, do all that, and solve for a. So we have negative 4a, 3 times a is 3a, 3 times 1 is 3, equals a times a is a squared, a times 1 is a. All right, and then we want to get all of our a's to one side, but since we have an a squared, we're just going to get everything to one side because that means we're probably going to have to factor. So because the a squared is already positive, I'm going to move everything from the left side to the right side in just a second. So I'm going to combine these like terms first. So we would have negative a plus 3 equals a squared plus a. So I'm going to add a to both sides and then subtract 3. So these cancel because that was our goal. And then we have a squared, combined like terms, we have plus 2a and then minus 3. So remember to put it in descending order so you know you can factor. All right, and then we're going to factor. So figure out what multiplies to negative 3 and adds to 2. So that would be a plus 3, a minus 1. And then we set both of those factors equal to 0. So a would equal negative 3 and a would equal 1. So make sure both of those solutions work against our restricted domain. We just said a couldn't equal negative 1 or 0. It's okay for it to equal positive 1, and it's okay for it to equal negative 3.